All right, so our goal today is, like yesterday, solve the equation by isolating the trig function. What makes today harder than yesterday is not really the trig, it's the algebra at the start of the problem. And so, I don't know, this is kind of a funny line to throw in here, but we must use good algebra techniques to do this. Don't get lazy with your algebra. So today is a combination of algebra and trig. Yesterday was all trig. The warm-ups was all algebra. Today we'll put them together. All right, there's kind of two different things we can do. Roman numeral 1, isolating the trig function by raising each side to a power. Sometimes when isolating the trig function, you must raise both sides of the equation to a power. You've done this before, we just haven't done it with trig functions. So some simpler algebra type problems. If we have the square root of x equals 5, what do we do to get x by itself? Square it. So we would square both sides. And x would be 25. So that's the algebra part of it. Separate problem, if we had x squared equals 9, what would we do to both sides? Square root it. And what would our answer be? Good, plus or minus 3. So that's the algebra background stuff that we're supposed to be good at already. Remember, when raising each side to an even root, as in square root, fourth root, sixth root, no, not that we ever really do those, mainly the square root. You must use the positive and the negative of the other side. And the blank there is just for like plus minus. Hey, don't forget the plus minus. When you square root both sides, don't forget the plus or minus. Now for trig, this is kind of good news, because if our answer is the plus and the minus, then when this happens, you need to put your reference angles in which of the quadrants. If we're allowed to have the positive and the negative answer, which quadrants will that be in? What's that? I think somebody said it. All of them. And so in some ways it's easier because you're not really worried about which quadrant it's in. It's in all 4 quadrants. Sine's positive up and negative down. Cosine's positive right and negative left. But none of that matters if you need the plus and the minus. Then you just use all 4 quadrants. So probably the biggest thing on that is if you square root both sides, don't forget the plus or minus. You know what? Let's skip down and do number 1 while we're thinking about that. 18 cosine squared x equals 9. So what should we do first? Let's divide by 18. So cosine squared of x equals 1/2. Then we'll square root both sides. Now, we just talked about what to do, so I know you're not going to forget it right now. I hope. The plus or minus. The trouble is, if it's test day, and this type of problem is buried among 15 or 20 other problems, will you remember to put the plus or minus on it on that day? I hope so. That doesn't look like a unit circle value, though. What can I do to fix that? It helps to see it like that, maybe. Yeah, multiply top and bottom by square root of 2. So cosine of x equals plus or minus square root 2 over 2. And it's plus or minus, so I don't really care what quadrant. I probably shouldn't phrase it like that. It's in all 4 quadrants. But what's the reference angle? What denominator? It would be over 4. All the over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Sounds like those first few steps are algebra. And then that last step is, do you know the unit circle? So there's multiple places to mess this up. This is sometimes not fun to grade because if a student makes an algebra mistake, obviously they're going to miss the problem. And then some students are going to get their algebra right but not know the unit circle. You got to be able to do both. All right, back to the notes. So that was an example of square rooting both sides. Don't forget the plus or minus. But again, in some ways it makes it easier because you don't have to worry about quadrants. Roman numeral 2. Isolate the trig function by factoring. As with algebraic equations, we often need to factor a trig equation. First, manipulate, you probably wouldn't have guessed that word in there, the equation to get 0 on one side. All right, we could have just abbreviated that, get 0 on one side. That's what the warm-ups tested, right? Those first two, I was trying to bait you into doing something you're not supposed to do, and nobody would take the bait, which is good. You got 0 on one side. This is a crucial step. We're just repeating ourselves here. Don't forget to get 0 on one side if you're going to factor. I don't know. That's a little repetitive in the notes there. I guess I can say this. It reminds me sometimes in the Bible, like the authors will say the same thing back to back. It's like, this is really important. I'm going to say it twice. Get 0 on one side. Hey, by the way, if you're factoring, get 0 on one side. That's repetitive, but it's important. Speaking of repetitive, factoring to solve an equation works only when you have 0 on one side. Let me try to say the same thing 3 different ways so that we recognize its importance. And again, that's why I did the warm-ups, but nobody fell for it. So hopefully that repetitiveness is unnecessary. Sometimes you can factor right away. Look for you know what blank that is? Look for a blank to factor out what is in common. So what's a short thing that could go in that blank? What's the first type of factoring we're supposed to look for? It's not always there, and it's why we don't always look for it. But it was in one of the warm-ups. GCF. Look for a greatest common factor. It's not always there, but it makes life easier if it is. Letter D. If you can't factor right away, you may need to get your equation to have only one trig function. Meaning make it be all sines or all cosines or all tangents. And we may need to use trig identities to do this. Usually, probably only for us, it's the Pythagorean identities. There's not much room here, but that's the sine squared plus cosine squared equals 1, and the other two that go with that. And so when we need them, probably most of you don't have the other two memorized. I don't have the other two memorized. I have the first one memorized, and I can get the others if I need to. Then treat the trig function like a single variable, say u, and factor. Okay, that might sound weird, but we'll do an example in just a minute. After you factor, you set each factor equal to 0 and solve for x like we did yesterday. So there's some algebra at the front end, and then it's exactly like what we did yesterday. So number 2. State the values of x which satisfy this equation. What can we do first with that equation? Do you see something we can do? Factor out cosine of x. Right, there's a common factor. So I'm going to factor out the cosine. I'm going to sort of unmultiply it, put it back out front. What's going to go in this first blank? Cosine times what would give me 2 sine cosine? 2 sine. And then, good, plus 1. Although some people, they're like, oh, I took the cosine, it's gone. Like, well, no, the cosine's gone, but you still need a plus 1 in there so that if you distribute it, you still get the cosine. So it doesn't just go away. You need the 1 there. All right, now we'll set our two factors equal to 0. Cosine of x equals 0. 2 sine x plus 1 equals 0. And I'm going to press pause and let you see if you can finish it, because from there, that's exactly what we did yesterday. Factoring turned this from one hard problem, really one impossible problem, into 2 easier problems anyway. Maybe not easy, easier. So try those, and then we'll see how we do. Pi over 2 and 3 pi over 2. But some people didn't have that sketch. I guess they just thought in their brain, the top and the bottom. So pi over 2 and 3 pi over 2. So picture not necessary, but maybe helpful. Sine of x equals negative 1/2. So that would be in the down quadrants. Or some people label all students take calculus and then realize it's the down quadrants. Sine is 1/2 at the over 6s. So that's the shallow angles. So 7 over 6 and 11 over 6. So that's a fairly simple, the simplest one you'll get today probably was example 2. A little bit of algebra, a little bit of unit circle. Obviously we could turn up the difficulty on either one of those parts to make the problem harder. Or on both parts if we really wanted to make it fun. Number 3. Find the values of x on 0 to 2 pi which satisfy that equation. So what do you see that we could do first on number 3? Factor out the tangent. So I factor out a tangent. Factor out a tangent.
Should we change the secant to...
Yes, we should eventually change the secant. Like the secant is a problem, but I don't want to change it yet. So you're right. Secant's weird. We'll worry about that in a minute. Secant x minus 2 equals 0. So now we set the two factors equal to 0. So tangent of x equals 0. Let's see. Tangent is y over x, so the y is 0. Or it's sine over cosine, so tangent is 0, the same place sine is 0. That's 0 and pi.
Would 2 pi also be an answer?
Oh, you're right, because we do need to include 2 pi. I'm used to working it where we don't include 2 pi. That's why I mentioned that earlier. But this wants us to include 2 pi, so yes. On the other piece of the problem, secant of x equals 2. Now, Tyler, how do you want to fix secant? You're right, we want to do something to that. So it's related to cosine, yes. There's a couple ways to do it. Let's do it the long way around first, because that'll make sense of the shortcut. Just straightforward, secant is the same as 1 over cosine. And then I can flip both sides. Right? I can flip it over and get cosine of x equals what? 1/2. Now, most people, after they've done this type problem once or twice, they start to realize, wait a minute, why don't I just not show that middle step? Why don't I just flip both sides? And I know that the flip of secant is cosine, so I can jump straight to cosine equals 1/2. Let's see, cosine is positive on the right, and that's the steep one. So that's pi over 3, and something else over 3. What's over 3 in the third quadrant, or the fourth quadrant, excuse me? 5 pi over 3. So I guess today is kind of complicated because it involves two things. On the other hand, if you're good at algebra and you understood what we did on Tuesday, those are the two things it involves. All right, number 4, things get a little different here. Yeah, I can't. Well, I could factor out a cosine, but then it's not equal to 0, so we need to make it equal to 0. So 2 cosine squared x minus 3 cosine x plus 1 equals 0. Some people can factor that by looking at it. Other people are like, I don't like the cosine. Let's do a little bit of a u substitution here and make this problem easier to look at. It doesn't really change the math of the problem. It just makes it easier to look at.
Cosine squared plus 1 is that would be like sine?
No, because it would be sine squared plus cosine squared is 1. So 1 minus cosine squared would be sine squared. And we wouldn't want to do that anyway, because then we'd have sines and cosines in this problem. So yes and no. But are you okay with what I did, even if you don't understand why I did that? Because now the factoring, I mean, it's the same factoring as it would have been. It's just going to look a little bit easier, look a little nicer. Let's see. So it's got to be 2u and u to get u squared. To get 1, the only options we have are 1 and 1, so I hope this works. Let's see, if that term's positive, they have to be the same sign, but they're both negative. And then we check it. So negative 2u minus u equals negative 3u, so we factored it right.
Cosine of x
but what the heck are those U's doing in there?
2 cosine of x minus 1.
2 cosine of x minus 1 and cosine of x minus 1 equals 0. This is another one of those places where some of you are going to say, you know what, I don't need those U's. I mean, yeah, they make life a little easier, but I can do it without it. So if you can handle factoring without putting their U in there, that's fine. You're going to land at the same spot. We set them equal to 0. And this is another place where people start skipping steps. Like you always skip this step when it's just, in fact, I don't even know that we showed the step when we did warm-ups. Yeah, x minus 6, x plus 1 equals 0. We did not show the step where we set them both equal to 0 because you've done it 100 times. You just move the 6 over, you move the 1 over. You can do the same thing here. Cosine of x equals 1. Now this is a problem like yesterday. Let's see, cosine's 1/2. Add pi over 3 and 5 pi over 3. I feel like we just did that problem. We did. That was the kind of the same as the one we just did. And cosine's 1 over there, 0 and 2 pi. Number 5. What do you want to do first on number 5? Good. Move the cosine over. Not divide by cosine. Move the cosine over. What do you want to do next? After we move the cosine over, factor out a cosine. So see if you can take it from there. We can factor out a cosine. See how far you can go on your own from there. The second part of this factoring job that's a little bit tricky. Cosine of x equals 0. Let's see, that'd be pi over 2 and 3 pi over 2. That's the easy one. A few people tried to factor this, but you can't. I mean, you can't factor that with integers. You can factor it if you get kind of goofy, but you can't factor that. So let's solve for cosine of x by moving the 1 over, dividing by 2, and then square rooting. So cosine of x equals plus or minus square root of 1/2, or 1 over square root of 2. And then we fix it. So now it's a little bit better. In fact, I feel like we did that one as well earlier. Right? There's only so many spots on the unit circle to land on, so you start getting repeat answers. Let's see. I'm not really concerned about quadrants because it's plus or minus. I'm more concerned about reference angles. For 2 over 2, that's the one in the middle. So I need all the over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. It's got that 2 in there. What will we, so when do we handle the 2? At the end. So yes, we're kind of worried about it, but we're not worried about it right now. So tangent squared of 2x equals 1/3. A couple of algebra steps at once. Square root both sides to get tangent by itself. Don't forget the plus or minus. another one that doesn't look quite right. I need to fix it. It's especially dangerous because if you try the tangent 3 trick without fixing it, you're going to get the wrong answer. Once you fix it, root 3 over 3, then the tangent 3 trick tells you what's the denominator we're looking for. 6. And plus or minus means I'm not really worried about quadrants. I just want all the over 6s. Although, goodness, there's going to be a lot of answers because of that 2x. So pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. But I'm not done yet. How do I handle the 2, or what do I have to do because of the 2? I will multiply by 1/2, but not yet. I need to do something before that. I need double the number of answers. So how do I get my extra answers? I had 2 pi to all of those guys. The good news is they all have the same denominator. So how about we do it this way? For all of those, I'm going to add, not add or subtract, I'm going to add 12 pi over 6. So 13 pi over 6, 17 pi over 6, 19 pi over 6. It's a good question. I'm over 2 pi. Yes, sort of. But when I divide by 2, I won't be over 2 pi anymore. So you're right to be concerned, but we don't really need to check that until the end. Alright, divide all those by 2, or multiply them all by 1/2 would be an easier thing to do. Lovely set of 8 answers there. Oh, and I couldn't quite make them all fit on one line. Again, a little bit of algebra, a little bit of unit circle. But it's an algebra that some people struggle with, and some people still struggle with unit circle. So there's pitfalls and landmines everywhere on today's worksheet. All right, last one. And there's some box over there with some question in it. We'll worry about that in a minute. Okay, what are the x-intercepts? X-intercepts, what's that mean? What about, what'd you say, Tyler? Where it goes over the x-axis, okay. So just like generically, I have no idea what that graph looks like, but generically that means where it crosses the x-axis. What's happening, like ordered pair-wise, when x is, or when the graph is crossing the x-axis? Y is 0. So that's, speaking of algebra that we've forgotten maybe, x-intercepts means y is 0. And so now this is set to 0 for us. Let's see. I think I can take out a sine of 2x. There's one of those in both of those. So sine of 2x times tangent of x squared minus 3. Well, it's multiplied to the sine, so when we factor it out, the 3 is still there. So sine of 2x equals 0. We'll have to do the double thing on that one. And tangent squared x equals 3. I guess we'll just take them in order. So sine's equal to 0 at 0 and pi and 2 pi. But I gotta have double the number of answers because of the 2 there. So 3 pi and 4 pi. And I think that's it, right? Add 2 pi to all of those. And then divide by 2. That, the 2x there doubled my number of answers. On the second part, square root both sides. Don't forget the plus or minus. But again, you start to like the plus or minus because it means you don't have to worry about quadrants. It's all the quadrants. What's the tangent 3 trick? What's my denominator going to be? Wait, what's my denominator going to be? There's only one 3 there, so my denominator will be 3. So all the over 3's. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Alright, last box there. What if you have sine of x equals 3? Let's think about the graph of sine. Looks like that forever and ever. How high does it get? What's the max it gets to? 1. Peaks at 1. And what's the minimum it goes to? And so that's the graph of. So can you answer the question now? Where does the sine equal 3? Where does sine of x equals 3? Hint, it's kind of a trick question. It doesn't. It never gets there. So that would be no solution. Because there's no place where the sine's equal to 3. It just doesn't get up that high. Alright, your assignment is the next worksheet. Worksheet 3. Now there's only, let's say this, there's 3 more worksheets, but 4 more days, I think. So at some point we're going to run out of worksheets. That's a good thing though, right? So today was worksheet 3. Tomorrow is worksheet 4. Monday will be worksheet 5. But worksheet 5 is the last worksheet, I think. Yeah. But it's kind of a long worksheet, so you can start thinking worksheet 5 odds on Monday and worksheet 5 evens on Tuesday. Something like that. And again, not that you really want to fly through and work all the way ahead, but there's nothing new after today. It's just, it takes a lot of practice to be able to put everything together, the algebra and the trig.